Graphing and transforming absolute value equations. First thing I want to do is look at a simple graph of y equal the absolute value of x. So this is the parent function, the most simple absolute value equation you can make. To graph this, I first want to make a table, and I'll pick some values, -3, -2, -1, 0, 1, and 2. So if I plug in -3, remember absolute value is always positive, so it becomes 3. -2 becomes positive 2. -1 becomes 1. 0 is 0. Absolute value 1 is 1. Absolute value 2 is 2. And the absolute value 3 is 3. When you graph those, notice it hits the origin. 1, 1, and -1, 1. 2 and 2, -2 and 2, and 3 and 3, and -3 and 3. Note that it makes an absolute perfect V, and there are points between. For example, the absolute value of 0.5 is 0.5. Absolute value of 0.75 is 0.75. So it's a straight line on each side going up diagonally. It makes a perfect V. Note that when you say the absolute value of x, y is always positive. There's no way to make y negative unless maybe I put a negative in front of the absolute value. But really what's going on is this is two equations all wrapped in one. It's y equal x, that's when x is positive, and y equal negative x, because when I take the absolute value of negative x, it becomes positive. But again, keep in mind, y is always positive. So these graphs are correct, except for y can never be negative, which is why we get a perfect V. Here are two transformations of y equal the absolute value of x. So here, x has been replaced with x minus 3. Since x is being replaced, we know it's horizontal. We know the horizontal is the inverse. Minus 3, think of the x-axis, seems like it would be moving to the left. But because what happens to the points and what happens in the equation are inverses, this actually moves it 3 to the right. So 0, 0 would have been a point on the parent function, now becomes 3, 0. Note that if you plug in 3 in this equation, 3 minus 3 is 0, and y is 0. The absolute value is 0, 0. That's the only change. This is a transformation or a shift 3 to the right. The rest is exactly the same. Remember how the equations were y could never be negative, but the equations were y equal x and y equal negative x, understanding that y could never be negative. The slopes are 1 and -1 on each side. It's exactly the same graph, just shifted 3 to the right. Let's take a look at this one. So this is a transformation on the parent function. X is being replaced with x plus 2. Since x is being replaced, we know it's horizontal. Plus 2, think of the x-axis, seems like it'd be to the right, but because it's horizontal, it's actually a shift 2 to the left, because horizontal is the inverse. So that point, 0, 0, would end up getting moved right here. Minus 3, that takes every y value and shifts it down 1, 2, 3. So the origin moves to right there. The rest of the graph is exactly the same. Last example, let's throw in a reflection. Every y value will be the opposite of what it would have been, except after that we're going to do a vertical shift, vertical transformation, translation, up 1. So first of all, start inside. We have a shift, plus 3. It's a replacing x, so it's the inverse, so it actually moves it 3 to the left. So 0, 0 is where we're starting. We're going 3 to the left. Then normally the graph would have been right here, slopes of 1 and -1 on each side. However, that's not correct because it will everything will now be negative because of this negative out in front. So it would normally then be right here, but hang on a sec, that's not the answer. I'm just showing you. After that, we're going to move everything up 1, so everything will get moved up 1. So our final answer, I'll do that in black, is everything gets moved up 1. On the left, we have a slope of 1, up 1 over 1, up 1 over 1, or down 1 over -1. And on the right, a slope of -1. Let's try that again. Let's take a look at some simple values for different transformations. What we're going to do is transform this function and do each kind. Let's do a vertical shift. Let's say we wanted to move everything up 5. Well, y is being affected, y, so my equation is going to have every y increased by 5. It's not an x or horizontal transformation, so what we do is we have a -4 plus 5, which means my new equation will be 2 times the absolute value of x plus 3 plus 1. Horizontal shift, let's move it 5 to the left. So my equation is going to have x change. 5 to the left, that seems like it'd be -5, but it's the inverse, so it's actually +5. So x gets replaced with x plus 5. Now this is taking the place of x. I still have a +3 in there and a -4. Now my final answer then is 2 times the absolute value of x plus 8 minus 4. Let's take a look at a vertical compression. With a vertical compression, y is being affected. So my new equation, let's do a vertical compression of a factor of 1/2. Notice that my factor is less than 1. That's what makes it a vertical compression. So every y is going to be affected. Now this is important. This whole thing is y. So I'm going to take 1/2 times that whole thing. I'm going to use brackets for that. 2 times the absolute value of x plus 3 minus 4. Keep in mind, this is one term, as is the forward term. I do not take the 1/2 to both the 2 and the x plus 3. First of all, you will never distribute inside an absolute value. That's just a bad practice. Don't do it. What I'm going to do is take 1/2 times this whole first term. 1/2 times 2 is 1. So it just becomes the absolute value of x plus 3. But I'll also take 1/2 times the second term, that's the 4, and 1/2 times 4, -4, becomes -2. Horizontal compression. Horizontal is the inverse. That's why we replace x with 1 over b times x. X is being replaced because it's horizontal, and it's the inverse. That's why it's 1 over b. Now, if it's a compression, that means my b is less than 1. Like, let's do a 1/2 again. So my equation becomes y equal 2 times, I'm going to replace x with 1 over b, 1 over 1/2 times x. 1 over b times x, plus 3 minus 4, which becomes y equal 2 times the absolute value. Now 1 divided by 1/2, I'm going to multiply by the reciprocal. So that second fraction, the bottom fraction, gets flipped, becomes 2 over 1 times 1, the 1 up top, which is just 2. So it's 2x plus 3 and then minus 4. A vertical stretch. That's when my factor is bigger than 1. Let's do times 3. Every y value is going to be affected. Since every y value is affected, I need to multiply everything by 3 because that whole equation represents y. 3 times 2 times the absolute value of x plus 3 minus 4. So I'll distribute that 3. Again, keep in mind that is a term and that is a term. I do not take 3 inside the absolute value. It becomes 6 times the absolute value of x plus 3 minus 12. Last example here, horizontal. X is going to be replaced with 1 over b times x. Since it's a stretch, my b is bigger than 1. Let's do 3 again. Y equals 2 times the absolute value back to the original equation, x plus 3. So x is going to be replaced with 1 over b times x. 1/3 x plus 3. Close your absolute value, and then a minus 4. Keep in mind, we always went back to the original equation each time. If it's horizontal, we replace x with 1 over b times x, or if it's a shift, x plus or x minus. And with vertical, I've always got to keep in mind, if it's a compression or a stretch, the whole function is going to be changed because y is equal to the whole function. We're past the teaching part. These are examples off the assignment. You probably will have questions towards the end of the assignment because I threw in a bunch of different functions. That's just to point out that they're all the same. You treat them all the same way. Transformations affect functions the same way if you follow the rules we've been working on. Let's take a look at this first example. Sketch y equal to the absolute value of x. I already did that. Remember, the absolute value is 0, 0. The absolute value of 1 was 1, 2 was 2, and 3 was 3. Makes that perfect v. This is the parent function of the absolute value. Y equal the absolute value of x minus 3. X has been replaced with x minus 3. Since x is replaced, it's horizontal. Horizontal is the inverse, so instead of moving it to the left, it moves it to the right. So the first point is at 3, 0. Notice that 3 minus 3 makes 0. Absolute value 0, 0. The rest of the graph is exactly the same. The slopes are 1 on one side and -1 on the other. You can always make a table if you get confused. In this example, we have two transformations. X has been replaced with x minus 2. That makes it horizontal. It's the inverse. So instead of moving it to the left, it moves it to the right. So 0, 0 moves to right here initially. Then after that, we have a plus 4. So everything will get moved up 4. So there's where 0, 0 goes, right there. And just like the last ones, the slopes are 1 and -1 on each side. In these two examples, you just have to identify the right equation. The parent function point of 0, 0 has been moved to -2, 4. You could see which one had a solution of -2, 4. That would work. But we know that if it's moving to the left, it's horizontal, and that's the inverse. So instead of -2, it's +2, which immediately eliminates those. And so it must be this one. This equation would move everything 2 to the left because x is the inverse, and up 4. That's the vertical transformation. The second one below, the graph is moved to the left. -1, -3. Going to the left is horizontal, so it's the inverse. So there should be a +1 on that. And this is the only one that would possibly work. This equation we're going to shift to the left 28 units. So this becomes y equal to absolute value of x to the left. That's where it seems like it ought to be minus, but it's the inverse, so it's plus. So it's plus 28. Compress vertically, so y is going to be affected. Every y will get multiplied by 1 over 81. And then downward 21 units. So I'm going to move every y value downward 21 units. The bottom one, the absolute value parent function has been shifted 4 units to the right. That's horizontal. It'll be the inverse. So instead of plus, it's going to be minus 4. And 3 units up. Going to increase every y value by 3. This top one is a 1-step. We're going to move everything down. That's vertical. So y is being affected. So this is g of x equals my new function g of x plus 8, and then minus 6 will be minus 6, and then we're going to go down 13 more, minus 13. So my g of x equation is the absolute value of x plus 8 minus 19. Find the function created from f of x equals the absolute value of x minus 1 minus 2 after translation 3 right. Going to the right is horizontal. Horizontal is the inverse. So my new function is going to have x replaced. 3 to the right. Seems like it should be plus, but it's the inverse. It's minus. So x will get replaced with x minus 3. Then I have a minus 1. And then that minus 2 afterward. So g of x will equal the absolute value of x minus 4 and then a minus 2. Find the function created from f of x equals negative 9 times the absolute value of x minus 7 plus 4 after vertical stretch. It's vertical, which means y is going to be affected. This is y right there. So my new function is going to be g of x equals, now every y is going to be affected. I need parentheses or brackets. I'm going to take 2 times every y. Negative 9 times the absolute value of x minus 7 plus 4. This is one term and this is one term. So I take 2 to each term. Do not take 2 through the absolute value. This whole thing is one term. It's not necessary and it would not be correct. So 2 times the first term becomes negative 18 times the absolute value of x minus 7, and then plus 8 when I take the 4 times 2. Find the function g of x created from modifying that function a horizontal stretch by a factor of 6. It's horizontal, which is the inverse. X will be replaced with 1 over b times x. And since b is greater than 1, that makes it a stretch. So my g of x will equal negative 7. I'm going to replace x with 1 over b, and b is 6 times x, plus 2 minus 1. And that is it. For this top question, we're going to reflect over the x-axis. So I always have to think about what happens to the points. Here's my coordinate grid. Beautiful, isn't it? There's my x and y. Here's a point, x comma y. If I reflect over the x-axis, I go the same distance on the other side. X stays the same, note, and y becomes negative y. So every y value will be the opposite. So my g of x function, every y is affected. So the whole equation is what y is. This is y. So I'm going to have every y will be the opposite. So an opposite in front of my brackets. Negative 5 times the absolute value of 9x plus 7, and then plus 1. This is a term, and that's a term separated by the plus. There's times joins terms. Remember, 2x is one term because there's times between it. If I put a plus 1, it's now two terms. So I'm going to distribute the negative as a negative 1 to both terms. So my answer becomes g of x equals 5 times 9x plus 7. Notice the absolute value does not change. And then minus 1. Find the function below g of x after we reflect that function over the y-axis. So think of the coordinate grid. We're going to reflect a point x, y, and this time we're going to go over the y-axis. So straight across to the other side, x becomes the opposite, y stays the same. So this equation, g of x here, will be negative 2. X is going to become the opposite. So it's 9, and x becomes the opposite. Plus 8 minus 5. So my g of x function is negative 2 times the absolute value of negative 9x plus 8 minus 5. Now the mistake you could make is you might think, well, isn't that going to be positive? No. You've got to first take negative 9 times whatever x is, and it depends on what x is. If x is negative, then it would be positive, of course. But you'll take negative 9 times x, add 8, and then you'll take the absolute value. So don't make the mistake of thinking the absolute value affects that sign. It does not. These questions are random. These are at the very end of the assignment. There are a variety of functions, and just pointing out to you that it's all the same. Let's take a look. So we're going to take this exponential function, negative 2 to the power of 4x minus 2, and we're going to horizontally compress it by a factor of 2/3. Because my b is less than 1, it's going to be a compression. And because it's horizontal, I replace my x with 1 over b times x. So my equation g of x becomes negative 2 to the power of 4 times, and x gets replaced with 1 over b times x. So it's 1 over 2/3 x. So that's 1 over b times x minus 2. Now I'm going to have to multiply by the reciprocal, and that means I'm going to have to flip the 2/3. Now 4 is 4 over 1, so I take 3. When I flip it, I'll take 3 times 4, and that'll be 12 over 2x minus 2, which of course simplifies. G of x will be negative 2 to the 6x minus 2. Now if you have doubts about whether that looks like a compression, you could plug the original into Desmos and this into Desmos and look at them. Find the function created, that's g of x, by transforming this quadratic. We're going to horizontally compress it by a factor of 1/2. Since b is less than 1 again, it's a compression. It's horizontal. Horizontal is the inverse. I'm going to replace x with 1 over b times x, 1 over 1/2. So my g of x function becomes 5, 6. X gets replaced with 1 over b, 1 over 1/2 times x, minus 7 squared. I use parentheses for times. You could use a dot or whatever, but the 1 over 1/2 is going to get flipped. It's going to be 2 over 1 times 1 up top. You multiply by the reciprocal. So this becomes g of x equals, I'm going to take the 2 times the 5 and the 1/2 and the 1 times the 6 after it's flipped. This becomes 10 over 6x minus 7 squared. 10 over 6 does reduce, so my final answer, I'll circle over here, reduce that 10/6, divide them both by 2, it's 5/3 x minus 7 squared. Here are the last 3 examples from your assignment. Another exponential function. we're going to do a horizontal shift left of 3. So my g of x equals 8 to the power of 8. Now x is going to be replaced. It's horizontal, and it's the inverse. Left 3 seems like it ought to be minus 3, but it's the inverse, so it's plus 3 plus 8. Then we'll distribute that 8 and combine like terms. So g of x will equal 8 to the 8x plus 24 plus 8. And my g of x then is 8 to the power of 8x plus 32. Middle one is a square root function. A horizontal shift left of 2. So x is going to be replaced because it's horizontal. And since it's horizontal, it's the inverse. Left 2 is not going to be minus 2. It's going to be plus 2. So replace x with x plus 2 minus 6. Now I'll distribute the 9 and subtract 6. So g of x will equal the square root of 9x plus 18 minus 6. So for my final answer, I have the square root of 9x plus 12. Last one, horizontal compression. Since it's horizontal, I'm going to replace x with 1 over b times x. It's a compression because it's less than 1. So my g of x will equal 9/4 times 1 over b, and b is 2/3. So 1 over b times x plus 7. Now the 2/3 will get flipped, and I'll take the 3 times the 9 and the 2 times the 8. So my final answer is going to be g of x equals 27 8x plus 7 squared. Squeeze it in there at the bottom. This all takes some getting used to, but as you'll see, I've mentioned this over and over, you'll see this in every chapter, transformations on a whole variety of functions, including some I haven't shown you yet. But if you understand this right now, you're off to a huge head start.